thank you. Thank you very much for inviting me. And I'm going to say one of these things is not like the other. I'm not a toxicologist. I'm actually a nutrition professor. And I think I was brought in to talk a little bit about the models that we use. And I'm very much in support of NAMs for the triple R, but I do think that we will be losing something, at least in the short term. So again, these are my conflicts of interest. I do a lot of work with infant formula companies as well as ingredient producers for novel additions to infant formulas. So my outline, I'm going to kind of set the stage, talk about the unique aspect of human milk and infant formulas, talk about selecting animal models, and I do work with the piglet models, so I'm going to spend some time on that. So I think from a broader perspective as a nutritionist, we know that foods contain both nutritive and non-nutritive components, and these are in complex biological matrices, and we've really begun to appreciate that about human milk and infant formulas. And what we know is that many of these components have multifunctional, multi-organ effects, and that their functions can be impacted by the process of digestion and absorption. And while I believe the NAMs have a lot of possibilities, I think that at least in the short term, I don't believe that they'll be able to really capitulate whole body effects. And so I will be focusing on our work as piglets as a preclinical model. I'm going a little bit fast because I'm the cleanup batter and we're getting short on time. So again, I know Paul's here. He doesn't like this definition, and maybe our new group will work on a new one. But this idea, so I was part of a workshop between a joint NIH FDA, and we came up with this definition that these typically, at least a lot of different formulas, are non-human derived ingredients. They could be from bovine milk or can be made by fermentation processes or chemically synthesized. So this is this idea of trying to move these bioactive components into human milk to help to narrow the developmental gap between breastfed and formula-fed infants. And really, they do kind of blur that line between a food and a drug. And assessing their safety is difficult. And I will tell you right now, there's kind of been a hard stop at FDA in approving new novel ingredients. So I'm just going to highlight that this has been, we have stork speed, we have, closer to zero, but this has been in the hearts and minds of the FDA and NIH for quite some time now. There's a workshop, this was from, the workshop was actually held in 2020 and the paper published in 2022. Catherine was on this, but really one of the biggest concerns they have about these bioactive components is potentially long-term effects on the immune system. So not only allergenicity, but functional programming of immunity in early life. So this 11-member expert panel had a 2-day symposium. There was also another workshop with the joint NIH FDA workshop on the science surrounding it, and we published a paper. And then there was an expert comment from the FDA on that. So again, if you're interested in this space, there's publications. So I'm just going to go quickly on this concept of human milk as a biological system. And really, this understanding, it's not only the components in human milk, but it's the complex matrix, which is at this point almost impossible to recapitulate in infant formulas. And we also know that human milk is what we call now a system within a system within a system, so that human milk is a biological system. It sits within the mother-infant triad. So if this baby has a cold, the mammary gland will sample the pathogens and will create antibodies towards it. So it's a very responsive system. And then they also sit within the external environment, so that if a mom's in Bangladesh, her human milk's going to look very different than a mom in Stockholm, Sweden. And so there was a workshop that was hosted by NIH called the Begin Project in different working groups. And I chaired the working group on how do we prove this? How do you prove bioactivity of complex systems, and how do we need to study it? And I think the bottom line, and where I think about this for a lot of components, is that, and you can say this doesn't have to be the infant, but Wally brought up the microbiome, is that if we look at a component, so I'll give an example of like human milk oligosaccharides, they may come in and they're going to potentially affect the microbiome, but that in turn is going to affect immune development. It could also affect gut development. It can affect neurocognitive development. So maybe we'll be able at some point to do this on a chip, but it's going to be really, really difficult. And so also within human milk, we have this idea that it's very dynamic. It affects the genetics, circadian SNPs, a huge SNP in human milk oligosaccharides, being a FUT2 secretor. And whereas infant formula by law and as such needs to be tightly regulated so that that infant who's getting this for sole source nutrition is getting a consistent product, but in no way reflects what a breastfed infant is receiving. So how do you select an animal model, or ultimately, how do you select a NAM? And again, I'm going to take you back to where we are. I'm not going to talk too much about this, but I believe very much in the replace, reduce, and refine animal testing. And this is where I think that the NAMs really can do a lot of the screening and maybe even get rid of some of the rat toxicology models. But we do eventually, particularly if this is something that's going into an infant, we need to make sure those systems reflect infant physiology. And that is not being reflected at all. And again, in the EU, I used to get a lot of funding from formula companies in Europe, and it's really completely dried up by the idea of completely replacing animal models. So, if we think about kind of this pipeline, so in vitro, so either cell culture or organoids, and there are people who are developing organoids from preterm infants, term infants, so they don't all have to be adult organoids, and this is particularly important for the intestine. And Wally just mentioned, so if you think about your intestine is not only important for digestion and absorption and metabolism, but it's also our largest endocrine organ and our largest immune organ. And if you're just doing KCO2s or something in a cell culture system, you're not going to reflect that at all, even doing cell culture. So these can be useful in a variety of ways, and I think they can inform that first screening for bioefficacy and potential application. So next would be some of the well-established rodent models, again, clearly for toxicology, whole body context, proof of concept, evidence, and identifying potential biomarkers. And again, safety, bioefficacy, potential application. But again, a lot of the current models are done in adult rodents. So for that reason, there's a large interest in moving to neonatal animal models, neonatal rat pups, but those are extremely difficult to raise. You have to do things like pups in a cup and put in catheters to feed them. So more studies have gone to the piglet model and the rhesus monkey, but again, all of these start to run into animal ethical concerns, and particularly with the monkey. But really, you can get, they're not going to be human infants, but I believe that we need to be getting some of this data before we start doing human clinical trials. This was way back in 2004. The IOM at that time developed this book. It'd be really nice to have one that's not 21 years old, but basically they talked around, at least for infant formula, we need to consider safety, but also screening of new ingredients, that the animal models may not be appropriate based on division, even decisions on safety. So rat and mouse have limited use. A non-human primate and piglets are more amenable. But as you'll see, there's been a recent paper from the FDA that came out not very long ago, which they do talk about juvenile animal models, such as neonatal rats and piglets, as well as clinical studies. And although we've seen some piglet studies in the grass, they're not as commonly used. And actually, the FDA approached my colleague Ryan Dilger and I a few years ago to actually asking us to help them assess some of the studies that they were getting in piglet models, because they don't really have the staff on hand. And I'm sure they don't have them now, but they didn't then to assess this. And I'm kind of leading into the fact that we do use piglets as a model. And one of the reasons I think, and I'll tell a little bit about the benefits of this, is that you can do a lot of the safety testing that you could do in a rodent model, but it's done in a developmentally appropriate animal model. So if you just are interested in growth, tissue weight, serum chemistries, we also do many measures of immune development, gut development, microbiome development, and with my colleague Ryan Dilger, neurocognitive development, so we can actually get to aspects of the gut microbiome brain axis. So these are why I think the pig is actually a better model than the rodent in many ways. So again, digestive physiology is nearly identical, and you can feed these on formula from birth. That homology in the immune system is about 80%. It's only 10% with rodents. So much of the work that's been done in rodents for immune system is, that's why some of these things are so difficult to translate. More similar microbiome composition, still not perfect, but you can actually do notobiotic pigs. And then the brain structure is very similar, and the growth trends. So again, with Ryan, we've been able to do, if you could click on, oh, he's gone, the piglet head model there. So we have basically established MRI, and he has a pig atlas for the brain, just like you would have for the human. And also, we've gone through a number of tests for learning and memory. This is a piglet doing a novel object recognition, which is completely translatable to human infants. And so, what I hear oftentimes is, well, these studies are really expensive, but this was just an example of an industry-funded research that within the same study, we have papers on growth and development, systemic immune development, neurocognitive development, and microbiome. And using predictive algorithms, we can actually start to put these systems together. So, what are the future directions? I want people to prove me wrong, so I'm looking forward to that, it might be impossible to fully recapitulate these in vivo effects. I'd love to see if we could do more in the piglet space and moving into NAMs. I do think that enteroids, because they do within a tissue capture a more intact system. I also think that co-culturing, so Wally just showed some examples where you might have intestinal epithelial immune cells, brain cells all on a chip. So, I am hopeful. I mean, I think it would be great if we could use fewer animals for research, but I think it's also sort of the fit for purpose. So hopefully that wasn't too fast.